OpenAI released a new model, which is actually confusingly called GPT-o1, and or more commonly, and I prefer to call it Strawberry, which seems to be what they were calling it as they were developing it, and what was hinted at by OpenAI executives, including Sam Altman, over the last few months. And it's not just a new model the way each previous model has been released. It is a new model, but it's really different, which I understand is maybe why it's now called 01. But why don't you give us an overview of what O1 is and does, and maybe what's different about it?
Sure. I'll do my best to try to describe what's different about it. I will say, with respect to the name, my understanding is that it's called Strawberry because the first era of models, if you ask them how many R's are in the word strawberry, you would get an incorrect answer because there are very few places on the internet in the training data where explicitly the number of R's in strawberry is counted. Right. And so there's not an ability to sort of reason behind that. You're just getting the fill in the blank sort of architecture that we're familiar with the GPT models to date. And so Strawberry has become the nickname of this new version because the version itself is focused more on reasoning than simply sort of trying to fill in the blank of the next word based on the most likely token to follow. So that's sort of like the background, and then as you said, O1, do you think that these naming conventions do you think they're intentionally trying to mess with us at this point?
Yeah, I think they're toying with us. I think they're just trying to see if we'll keep going along. I really do.
Same, same. They obviously could market these better and label them in ways that we could understand them. But as you said, Bridget, O1 has become the name because it's a new class of models. So before we know, the GPTs to date have been trained on all of the information on the internet, lots and lots of books and writings, and they predict the next most likely token or word in a sequence. This, on the other hand, really digs into the reasoning process itself. And I know we're using reasoning and thinking and we're anthropomorphizing the tech, but I think that it's the only way to really describe it in a way that's understandable. So rather than just focusing on the output and guessing, it tries to supervise the process of reasoning out the answer to a question itself. And so to me, it's sort of the difference between grading a fourth grader's math homework and seeing if they got the right answer versus being able to look inside their brain and watch them every single step of the way as they're trying to figure out an equation and making adjustments at different points so that they can get to the right answer. So the difference here is really in scale and scope, and in comprehensiveness of what the technology is analyzing and how it's strengthening the reasoning process. And so its intended or expected applications will be for really highly complex problems in specialized fields. Right now, GPT-4o, which we've been using as the sort of most cutting edge frontier model from OpenAI, remains, to my mind, the easy solution for most of the tasks that we do in a word-based world. But this technology is a game changer. It will advance and accelerate all of the tech that we've been following for a while. And so we thought it was important to really spend a little bit of time helping lawyers understand the distinction and what we think the long-term applications and implications will be. How are you understanding it in a way that might be clearer than how I just described it?
No, actually, I think your analogy to grading the math homework versus seeing the steps the fourth grader is making to get to the answer is really kind of a great one. I have a couple others. Well, first of all, I should say it does count the R's in strawberry correctly, right? It is doing, this model actually does do that correctly in a way that ChatGPT-4 or GPT-4 does not. So it clearly does do something different. I'm cheating now and stealing from Kevin Roose and Casey Newton on the Hard Fork podcast, but they put it in a way that helped me understand why it was different and important. And I'm going to try and explain how they put it, or at least I'm going to explain it in the way that it made sense to me, which is the previous models have all been trained on the amount of data, and their abilities depended on how much data they were trained on. And the general rule of scaling was the more data they were trained on, the more data that they learned, the better they were at producing outputs. And so that's why GPT-4 is better than ChatGPT. Each model is trained on more data, and it performs better. But this new model, O1 or Strawberry, is trained not on more data, but rather on the ability to, like we've been saying, reason, to sort of think through a question or a problem step by step, both kind of forwards and backwards, and to take its time in thinking through those steps, and even to show its work. If you've used it, it kind of, it doesn't show every single step, but it shows kind of how it's thinking through the answer it's about to give you. And what's important about that, or what's significant about that, is it's an entirely new way to scale these models. Which is not to say that the first scaling methodology is done. There is always more data to train on, and I don't know if we've talked here about synthetic data, but we can talk about that eventually. But there's always more and more data that the models can train on and scale for that reason. But now they can also scale in this other way, by being better and better trained at reasoning and carefully thinking through a problem. And it just is an entirely new way to grow and scale the models. And it that that helps me understand how significant it is, which isn't to say that I have had a lot of physics or advanced math needs for Strawberry yet. But I am pretty taken aback by what it's going to mean, I think, for how quickly these models are going to, impact so many important fields. I think you've probably followed the places where people are already seeing a difference, and I don't think lawyers are probably yet the folks who are getting the most out of Strawberry. But what's your sense of where this particular model will have, or is already having, an impact and is likely to have the biggest impact?
Well, as you noted, Bridget, right now on the benchmarking tests, the model is performing at just much more impressive levels than the GPT classes so far on mathematics and science. Just a couple of data points: in a qualifying exam for the International Mathematics Olympiad, the new version, the O1 Strawberry, scored an 83% on the test compared to what GPT-4o did at 13%. So enormous jumps. And it sort of reminds me of when we went from GPT 3.5 to GPT-4o, and we saw the jumps in the LSAT scores and the UBE bar exam. They were just exponentially better. Similarly, in coding proficiency, O1 reached the 89th percentile in Code Forces competitions. And in scientific reasoning, the next update of O1 is reported to perform similarly to PhD students on challenging benchmark tasks in physics, chemistry, and biology. And I've just heard lots of examples. I think one might be from the Hard Fork podcast of PhDs who have said that it took them a few years to figure out problems that it takes GPT or O1, maybe an hour to figure out. So the compression of time within which they're able to reason through these mathematics and scientific processes, it really is mind-blowing. And like you said, in our language-based profession, unless you're, in a very, very technical area or you have specialized training, you're probably not going to be able to tell the difference at this point between O1 and GPT-4o. And in fact, you might even think it is inferior because it relies on system 2 slower thinking, because it goes through every step in the reasoning process. So it takes longer for the outputs to be generated. And I found it not to be as eloquent as a Claude in terms of the way that it processes language. But it will be here in our language-based profession soon. And so we can talk a little bit about that, but I'd love to, focus on this back and forth process of not just moving in one direction, but being iterative and going back and changing parts of the reasoning process. And again, we follow our favorite Ethan Mollick, who wrote a great Substack piece and gave a good example that helps contextualize it, I think. I think you also followed his example, Bridget. Would you be willing to share his
Yeah.
example?
Yeah, I thought Ethan's example was also a great as always, he was able to, translate for lay people like me, why this is a significant step in these models. He had it, work on a crossword puzzle, and it was a pretty hard crossword puzzle. I mean, I'm not a crossword puzzle, aficionado. So maybe it wouldn't be as hard for those of you who are, but for me, just looking at it, it was a pretty hard crossword puzzle. And the previous models would often guess the first clue, and if it wasn't right, of course, it then couldn't couldn't complete the puzzle, because there was no way to do it. But Strawberry, or O1, was able to think out loud about what the potential answers to the first clue were, and then go to the next clue, to see if each of the potential guesses for the first clue would work with the potential guesses for the second clue, and then go back to the first clue to figure out the right one. And obviously, that's what our brains have to do to solve an actual crossword puzzle. And that's why most people do them in pencil, I believe, because you can keep, trying this, that, and the other thing. And Owen doesn't have to use a pencil, but it's doing the same kind of process. You actually used the term, Jen, a minute ago, system two thinking. And I think you're referring to Dan Kahneman's book of Thinking Fast and Slow. That's sort of the ways our brains work in two different ways. We have this like immediate instinctual, what you do at a stop sign. Your foot hits the brake. Your brain knows to do that. It does it without thinking. And then you have this other part of your brain, this like system two thinking, that can slow down and solve a complicated math problem, or maybe even a complicated calculus problem, or an advanced or applied math problem. And that's another way that I've been thinking about it. It's like Dan Kahneman, slow thinking by the model. And again, sorry for talking about the models like they're humans, but that is the weirdest thing about them. And that to me is how Ethan's example helped me understand the new capabilities. Do you think I got it about right? Or is there more that you would add to that?
No, totally. And it's the reason why the outputs are slower, right? Is because it is deploying system two thinking, like you said. And I think the idea long term is to be able to blend different models where I mean, we wouldn't necessarily be blending them, but the companies would be, so that we have really quick system one answers for things that are not that complicated, like an internet search, for example. And then we're able to give the AI more time to think through the system two type problems that are really thorny.